At this point, we've thought quite a bit about the musculoskeletal system in terms of body support and keeping the body lifted up off of the substrate with all feet in contact with the ground, standing quietly and just supporting their body weight. Starting with this web lecture, I want to start thinking about what happens when we start to put those bodies in motion and move around on the substrate. So one of the things that happens when you start moving those feet is that you create some level of possible instability. You run the risk of toppling over or falling over. So that's the first aspect of locomotion I want to start to think about. And we can diagram this stability by looking at an animal from a top view and thinking about the amount of support that it has beneath its body. And we can do this by sort of connecting lines between all of the feet that are in contact with the ground at any particular point in time. And when we trace out that shape, we can call this a polygon of support. So in this case, with all 4 feet on the ground with this turtle, we've got an irregular 4-sided polygon. At this next stage, with 1 foot off the ground, we've got a triangular polygon of support. With just 2 feet off the ground, what we have is a line of support. So just 2 feet, you draw a line between them, and that is your area of support. Now, we can also see the placement of this center of mass or center of gravity of the animal and where it lies with respect to this polygon or line of support. So in general, when the center of mass or the center of gravity of the animal lies within this polygon of support, or along right on top of this line of support, we say that the animal is statically stable. This is also called passively stable. So they're passively stable when the center of mass falls within a polygon or on a line of support. And what this means is that the animal doesn't have to do anything to prevent rotation about its center of mass, in other words, falling over. So there's no tendency for this animal to rotate about its center of mass as long as it's somewhere within this area of support. So with this turtle, in this example, what we see is that when it's being supported by just 2 legs, as in frame 3 and frame 7 here, it's supported by 2 legs that are on opposite sides of the body. So the forefoot and the contralateral hindfoot. Contralateral means opposite side of the body. And what this does is it makes sure that this line of support is going to go right through the center of mass, and this is going to remain statically stable. So let's see an example of what this looks like in a very stably walking turtle. So here we go. You can see 1 foot is being placed at a time. I'm going to keep looping that, and there's really no tendency for this turtle to rotate about its center of mass or wobble or fall over. It's a very nice, statically stable form of locomotion. If hypothetically, rather than using the 2 feet on opposite sides of the body, it used the 2 feet on the same side of the body. It's using its forefoot and the ipsilateral hindfoot, the hindfoot on the same side of the body. Now this line of support is far away from the center of mass, and there's going to be a tendency to rotate the body toward those 2 feet that are off the ground, and the animal will fall over. So in this case, it's going to rotate toward these 2 feet that are off the ground. In this case, it's going to rotate the other way. So this is not a very stable way of walking. So we call this dynamic stability. And this is a case where the center of mass falls outside a polygon or a line of support. And what this means is that this can only be stable if the animal is moving fast enough and or has long enough legs to catch itself before it falls all the way over. So there are definitely animals that do this. We'll see many examples as we go, but we would say that this is a much less stable way of walking than using these contralateral limbs in contact. So this is a very standard way of representing a gait or a stride. This is known as a gait diagram. And so what we have here is on this x-axis, we've got the percent of the stride. So from 0% of the stride to 100% of the stride. What is a stride? So a stride is a complete cycling of all the feet, regardless of how many feet the animal is using, from the placement on the ground of one foot, cycling through the foot placements of all the other feet, and coming back to the placement on the ground of that same foot. So in this case, we can see the left hind foot is placed in contact with the substrate. So this solid line along the y-axis next to the left hind foot indicates that that foot is in contact with the substrate during this portion of the stride. Where there's no line, that means that that foot is not in contact with the substrate. And so we can see this for all of the feet, and you can think of this as a cycle. As soon as you get to the end of this stride, the next stride starts, and this is just going to be a repeating pattern. So we call this period of time when each foot is in contact with the substrate, we call this the stance phase. The part when it's not in contact with the substrate, we call this the swing phase. This is when the leg is swinging forward and get ready for the next step with that foot. One of the things that we can calculate very easily from this kind of diagram is a quantity known as the duty factor. So the duty factor is equal to the percentage of the stride when a foot is in contact with the ground. So each foot will have a separate duty factor. Sometimes they'll all be the same, sometimes they won't all be the same. In this case, we see that we have the limb in contact about 0.75 of the stride, so we've got a duty factor of 75% for this foot. And in this case, the duty factor is the same for all of the 4 feet, about 75%. So this brings us to the question of what is a gait? What do we mean when we say a gait? So this is actually not a simple question. Lots of different researchers mean very different things when they talk about gaits. In general, we can say that they are different patterns of footfalls or energetic patterns with regard to locomotion that are non-overlapping. They're discontinuous, so you cannot be doing 2 gaits simultaneously. They're clearly distinguishable from each other. There's a break point between these 2 different kinds of locomotion. So one example of a way that we can distinguish different gaits is the difference between walking and running. And we can use this idea of duty factor as a measure of whether an animal is walking or running. So in general, we say that the animal is walking if it's got a duty factor of greater than 0.5. So this means that at least one foot is in contact with the ground at all times. This is what we call a walk. A run is a gait that has a duty factor of less than 0.5, which means that there's going to be some portion of this gait cycle, the stride cycle, in which there are no feet at all in contact with the ground, and we call this an aerial phase. When all of the feet are off the ground, the animal is essentially jumping or flying, right, for some short period of time over the course of that stride. So let's take a look at how we analyze these different kinds of gaits. So within walking gaits, we can have different footfall patterns, a different sequence in which the feet are going to come into contact with the ground. So here we have what's called a lateral sequence gait. So what do we mean by a lateral sequence gait? If we look at the foot placement of a hind foot, so in this case the right hind foot, the next foot that's going to make contact will be the ipsilateral front foot. So a placement of a hind foot is going to be immediately followed by the placement of the ipsilateral same side forefoot. So we can see here the placement of the left hind, followed by the placement of the left front, followed by the placement of the right hind, followed by the placement of the right front. This is a lateral sequence gait. And if we look at the lateral sequence gait in terms of the periods in which just 2 feet are in contact with the ground, so we see actually several different points in which there's double contact. How do we know when there's double contact? If we take a vertical line through this gait diagram and we're only intersecting 2 lines, that means that there are just 2 feet in contact with the ground at that point. So during some of these, you've got a left hind and a right front. So for example here, you've got contralateral limbs in contact with the ground, and remember that means that there's a diagonal line of support. You can have the center of mass located directly over that. That's more stable. That's also the case here, where you've got contralateral support on the left front and right hind. But in this lateral sequence gait, you also have these periods of double support where the weight is being supported by the two ipsilateral feet, left hind, left front, right hind, right front. If we look at the diagonal sequence gait, this is a gait that is characterized by the placement of a hind foot, so in this case the right hind foot, is going to be immediately followed by the contralateral front foot. So the left front foot follows the right hind foot. This is a diagonal sequence gait. The sequence is going to be diagonally across the body. And so same thing with the left hind is going to be followed by the right front. A diagonal sequence gait. So with the diagonal sequence gait, now if we look at these periods of double support, we only have two in a given stride cycle, one right here and one right here. And every time you've got double support, 2 feet in contact with the substrate, they're always contralateral feet. Left hind with right front, left front with right hind. So these animals that use this kind of gait always have that diagonal line of support across their body running right through their center of mass. So we can say that this is a statically stable gait. This is the most stable kind of walking gait. This, we would say, is a dynamically stable gait, the lateral sequence gait, because there are periods in which the center of mass is not located over that line of support. So usually we see diagonal sequence gaits primarily in arboreal species that are walking up on branches. They need to be more stable because any kind of rotation around the center of mass can cause them to fall from the trees and risk great bodily injury. We usually see these more dynamically stable gaits in terrestrial organisms, especially ones with very long legs that can easily catch themselves if they do start to rotate about their center of mass. So let's take a look at what this lateral sequence gait looks like in a cute little beagle. So what we're going to see here, the left hind foot placement right there is followed by the left front foot, right hind, right front, left hind, left front, right hind, right front. And if we look at the periods where only 2 feet are on the ground, they're going to be the 2 feet on the same side of the body. Right now on the left, right now on the right. You see both of the 2 left feet coming up now, both of the 2 right feet coming up. So this is a dynamically stable gait with periods of double support in which the body is being supported by 2 ipsilateral feet on the same side of the body. So now let's think about running gaits. So running gaits can be symmetrical or asymmetrical. A symmetrical gait is one that if you were to create sort of a plane of symmetry down the midline of the body between the left and right sides are behaving like mirror images of each other. They're doing the exact same thing, just out of sequence. The first kind of symmetrical lower speed running gait that we see is called a trot. And we can see that this is in fact a running gait. We've got 2 periods of aerial phase, so where the body is not being supported by any feet, so we know that this is a running gait. And in the case of a trot, we have the left hind working in coordination with the right front, so left hind and right front together, left front and right hind together, working diagonally across the body. Another kind of symmetrical gait that is not very often, but sometimes seen, is called a pace or a rack. And this is a case where the 2 left feet are working simultaneously and the 2 right feet. The only animals known to do this in nature are members of the camel clade. They will do this naturally. That's a normal, natural running gait. Horses can be trained to do this, but they do not do it naturally. So this is again clearly a running gait. You've got 2 aerial phases here, but you can see very clearly that this is a dynamically stable gait, right? There's a lot of opportunity for falling over, being on 2 legs on the same side of the body. You need to get those other 2 legs down quickly before the animal falls over. This is a much more statically stable gait, this fast trot, with that diagonal of support going across the body during the stance phases. So here is an example of a dog doing a trot. We can see that the left hind and right front work together, right hind and left front making contact at exactly the same time, in swing phase at exactly the same time. And so this is a statically stable gait in which that line of support goes right through the center of mass at all times when there are 2 feet in contact with the ground. At higher speeds, mammals switch to an asymmetrical gait. So this means that the 2 sides of the body are not working symmetrically as mirror images of each other. And one kind of asymmetrical gait is a gallop. A gallop is a gait in which the 2 front feet make contact in succession with each other. So one front foot and then the other front feet, and then the 2 hind feet make contact in rapid succession. So here we see the two hind feet. So right hind, left hind, followed by right front, left front. So this is a typical gallop. Hind, hind, front, front. And we can see here that there's just, in this case, a very short aerial phase right here at the end of the stride cycle. And in the case of horses, this aerial phase is with the feet all gathered together under the body. In other galloping species, notably members of the cat family, the aerial phase is going to happen in an extended posture rather than a gathered posture. Smaller animals, when they use an asymmetrical gait, will switch to a gait called a half bound or a bound. So in a half bound, both of the hind feet work synchronously together. They both push off together, but the front feet land asynchronously. So in this case, right front followed by left front. So we've got the 2 hind legs working together and then the front legs working out of synchrony with each other. And so you'll see that there are 2 aerial phases in this kind of half bound, one extended and one gathered. A full bound is similar to a half bound, except that the front feet come down together and work synchronously as well as the hind feet. And that is usually at the very highest speeds for small animals. So this is an asymmetrical gait used by small animals. Rabbits use them, squirrels, mice use this kind of asymmetrical gait. Larger animals, such as ungulates, like these horses, are going to use something more like a gallop. Dogs gallop, as we will see right now. So here's an example of our beagle demonstrating a galloping asymmetrical running gait. So here we have hind, hind, front, front, hind, hind, front, front. In summary, we've talked about a number of different kinds of gaits and different issues involved in stability while animals are walking. So when animals move around, there's a risk of becoming unstable and falling. Anytime you start lifting feet off the ground, you're not in as stable a state as when all of your feet are on the ground. So the feet that are in contact with the ground form a polygon or a line of support, or if there's just one foot on the ground, it can be even just a point of support. If the center of mass is within the polygon or on the line of support, the animal is statically stable and nothing needs to be done to keep it from falling over. It can just stand there for as long as it wants to. It's not going to rotate about its center of mass. Think of this as like a tripod chair, right, that's going to be stable. It's got 3 points of contact as long as the center of mass is right over it. If the center of mass is outside the polygon or off the line of support, the animal needs to take some kind of action to regain its stability or it will fall over. So when you stand on one leg and you just have a point of support, you need to shift your center of mass so it's directly over that point of support to be able to remain stable in that position. Walking and running gaits can be distinguished by the average duty factor of the feet. So duty factor greater than 0.5 is going to be a walking gait. Duty factor of less than 0.5 means that there's an aerial phase when there are no feet in contact with the ground, and that's going to be a running gait. Walking and symmetrical running gaits can be diagonal sequence, which is statically stable during double support, or lateral sequence, which is dynamically stable. So we saw in both of those cases periods of double support where the body is supported either by contralateral limbs, which is statically stable, or ipsilateral limbs, which is dynamically stable. That animal has to stay in motion and shift its center of mass to be able to keep from falling over. At the highest speeds, mammals switch to an asymmetrical running gait such as a gallop or a bound.